Hey guys, what's up? Saga here. I wanted to show you quickly what I've been working on this weekend. I know some of you are expecting the crafting strategies to come out soon. Right now, I'm deep into navigation, and I feel like if I change gears into crafting again, I'm gonna lose, freshness of all the code and all that stuff. So I wanna get the navigation out before the crafting strategies. At least that's the plan right now. And in the weekend, I managed to progress a lot. You might remember from my last video that I managed to extract the meshes from the game and to import them into Unity and then raycast into Unity. Well, it's been a journey. There's been a lot of problems with mostly memory, uh, memory overflows and such. But well, I managed to create an automatic mesher for Huerta's Western Highlands. That's the first mesh I've done. The automatic measure should work uh, well automatically for all the rest. But I wanted to first, test the algorithms, make sure they are correct, make sure they work as intended. Because it's not like I just read a manual of how to do this kind of stuff. A lot of the parts of the algorithm, like an A star Pathfinder is nothing new, but a lot of the interaction with the octree and all that I kind of pulled it out of my hat. So I wanted to make sure it actually works before meshing the rest of the zones and optimizing it and so on. So let me show you how I'm testing it right now. Um, Basically, I made a console application that takes a start point, an end point in the zone, and the graph, which I meshed with the auto mesher. Let me show you the graphs. It ended up being larger than I thought, but since Sextant is going to be on a server, it doesn't matter anymore because this time I switched from an obstacle graph like I had on the first iteration of Sextant to a free node graph just to get a little bit of faster performance on the Pathfinder by with the exchange of higher memory on the meshes. Let me show you. Well, the models, that's the zone's meshes. Um, then the graph, you see it's actually quite large, 37 megabytes. Well, once you compress it, it goes down to about 3.5 megabytes, but still, it is quite large. It's not something that you'll be downloading with Lisbeth. It's going to reside on a server, so it doesn't matter. Um, right, so paths. All right, let me delete this. All right. So basically, the console program takes a graph, which is a navigation mesh, takes the mobs, but we're not going to be testing that right now because I haven't made a visualizer of the mobs. But basically, the Pathfinder will, if a node is near a mob, the Pathfinder assigns it a higher heuristic value, so it kind of tries to avoid mobs if possible. We'll see that in another video, I guess. Um, so there's our start point and there's our end point. So I picked an actually hard path, as you'll see. I don't have the game open right now to show you which one is, but it's basically on Goertha's Western Highlands, and it's actually a difficult path because it asks to go around a hill and into a little hole in the ground. So the Pathfinder is actually going to have to do a lot of work in expanding nodes. Anyways, here's the Pathfinder, which is just you create the Pathfinder and then ask for the path. That's simple with a start point and an end point. There's a lot going below that, a lot going down in this method, right? But we'll not see that right now. Anyways, the Pathfinder right now is very slow. That's because it's not optimized, as I said. I wanted to first make sure that everything is correct, like that the Pathfinder actually works before beginning to optimize it. Part of the reason why it takes so long to find paths right now is because it creates and destroys a lot of objects, and that's causing the garbage collector to do a lot of work and stuff like that, which I can optimize later. Let me show you. Alright, so let's just run it. So test. How's the sound called? R2F1. Yeah, don't ask me why you have to type this 3 times. There we go. So you can see it took 430 milliseconds to find a path, which is, I think, not acceptable right now. I definitely want to take this down further, and I definitely can. As I said, I just have to optimize the pathfinding. It's really slow right now, but at least it's simpler to understand the code, and that's what I wanted, because I wanted to make sure it's correct first. All right, yeah, that's it. So we got our path, which is this file, and we also got the log, which the log is simply something that the Pathfinder spews out. It helps me. It's the thing that I then load into Unity to actually see all the things that the Pathfinder did, and so it helps me, debug the thing. This is the actual path. You can see it's just a bunch of nodes, right? It's actually very short. Now that it's smooth, we'll see that in a second in Unity. But the log actually has, a lot of stuff like the reconstructed path, which is actually very long. Then the unit path, and then the smooth path, and so yeah, the log spews out more information, and it's just to debug stuff. So, so here's my Unity project. I showed this the last video briefly without audio. It basically loads the zone's meshes, and then the path loader is going to load that log file, as you can see here, and draw the path. This is how I'm debugging the Pathfinder to make sure that it's working as intended. Because one of the things that I needed to test the most was the interaction between the Octree's supernodes and the pathfinding, which is actually a little bit more complicated than usual. So, anyways, here's the path. Yes, I know the dragon is missing. This is the one mesh in the entire zone, which gave me a stack overflow exception, so I couldn't import it. I'm guessing that the thing that I'm using to import the meshes, it's creating a lot of structs somewhere. It's causing the stack to overflow. Yeah, I might try to fix that in the future. Let's just increase the camera. There we go. You can see the entire zone. So yeah, let me show you then the path. So this is your start point. This is the point that I entered here, the start vector. Then this is the node which we are in. And then, yeah, that's the path. Basically, you can see that it goes around the textures. And the path that I chose, as you can see, it's not easy by path finding standards, because it goes around the hill, it goes around these obstacles here, and then finally it goes into this little hole in the ground. Let me try that, and into the destination. So there's many paths you could have taken, and I probably searched through all of them to find the fastest one. I probably searched around here. So yeah, it's not an easy path, right? It's not a straight line. Which, let's say you want to go from this corner of the zone to that corner of the zone. It's a longer path. It's an easier path, because since the Pathfinder uses a bias towards distance, it's actually going to expand very few nodes to reach that. So yeah, basically that's the path. You can see that it's very cubic, the movements. You can see it there, zigzagging and all that. You can see it here. You might say, well, why don't you just go straight lines, say, from the start, instead of going through all of these nodes, right? We could go just straight to this one, right? That's the part of the post-processing smoothing process of the path. Let me show you the path. Right now, the path loader here is showing the unit path, which is the actual nodes the path reconstructed into. And after the unit path, you get the smooth path, which I use a smoothing algorithm to post-process the unit path. Let me show you that here. We remove the units, and we add the smooth, and then we refresh. There we go. So now you can see the smooth path has a lot fewer nodes, and it's actually doing what we said, right? It's only taking the nodes in the corners. And well, you'd say, well, why did it need this node here? Why didn't it go from here to here? Because obviously you could do that in a straight line. Then again, you have to remember that this is the actual mesh of the zone. It's not the flight mesh. The flight mesh is calculated on top of the zone's meshes. For example, to see what the Pathfinder actually saw, let me turn on my player here. This red thing is my player. I used to test things. Let me turn on the obstacle drawer. Alright, so here's a better understanding of why I did that. You can see that there's actually a obstacle here. It couldn't go on a straight line. Let's try this. I guess you understand the idea. It couldn't go through a straight line because it would hit the obstacles. It had to go a little bit above. You can see that the lines actually go very close to the obstacles. They go just barely on the corner. That's because of the raycaster, but I think it's fine because most of these obstacle nodes, they're like the corners of them are a little bit away from the actual meshes in the game. So I think it's fine, even if it goes right through the corner of the obstacles, it won't hit the actual mesh. But yeah, basically, you can see this smooth path. It's actually much smaller and much more natural, the movement, until we reach our destination. You can see this node is actually kind of tricky. The path goes just barely straight through the obstacle, and the node is surrounded by obstacles. But yeah, basically that's the idea. I've been testing around different paths. I've been testing the Pathfinders. How long it takes to find the paths. Definitely need to optimize it a little bit, and yeah, but basically that's where I'm at right now. It's getting there. It's this was a very important step for me to actually see the paths that the Pathfinder was spewing out into the actual meshes of the zone. That was very important to make sure that the Pathfinder is correct. And yep, basically that's it. I'll keep you posted on any updates, but I hope that the flight service will be online this week. I just have to, optimize the Pathfinder and mesh the other zones, which I haven't done. And yeah, basically that's it. I'll see you later, guys.